Materials is a substance or mixture of substances that constitutes an object. Materials can be pure or impure, living or non-living matter. Materials can be classified on the basis of their physical and chemical properties, or on their geological origin or biological function. Material science is the study of materials and their applications. Raw materials can be processed in different ways to influence their properties by purification, shaping, or introduction of other materials. New materials can be reduced from raw to materials by synthesis. In industry, materials are input to manufacturing processes to produce products or more complex materials. Historical elements. Materials chart the history of humanity. The system of the three prehistoric ages, Stone Age, Bronze Age, and Iron Age, were succeeded by historical ages, Steel Age in the 19th century, Polymer Age in the middle of the following century, Plastic Age, and Silicon Age in the second half of the 20th century. Classification by use. Materials can be broadly categorized in terms of their use. For example, building materials are used for construction. Building insulation materials are used to retain heat with building. Refractory materials are used for high temperature applications. Nuclear materials are well used for nuclear power and weapons. Aerospace materials are used in aircraft and other aerospace applications. Biomaterials are used for application with interacting with living systems. Material selection is a process to determine which materials should be used for a given application. Classification by structure. The relevant structure or materials has a different length scale depending on the material. The structure and composition of a material can be determined by microscopy or spectroscopy. Microstructure. In engineering, materials can be categorized according to their microscopic structures. Ceramics, non-material inorganic solid. Glasses, amorphous solid. Metal, pure or combined chemical elements with specific chemical bonding behavior. Polymers, materials based on long carbon or silicon chains. Hybrids, combination of multiple materials, for example composites. Larger scale structure. A metamaterial is any material engineered to have a property that is not found in naturally occurring materials, usually by combining several materials to form a composite and or turning the shape, geometry, size, orientation, and arrangement to achieve the desired property. In foams and textiles, the chemical structure is less relevant to immediately observable properties than larger scale material features, the holes in foams and the weave in textiles. Classification by properties. Materials can be compared by and classified by their large-scale physical properties. Mechanical properties. Mechanical properties determine how a material responds to applied force. For examples include stiffness, strength, toughness, and hardness. Thermal properties. Material may degrade or undergo changes of properties at different temperatures. Thermal properties also include the material's thermal conductivity and heat capacity, relating to the transfer and storage of thermal energy by the material. Other properties. Materials can be compared and categorized by any quantitative measure of their behavior under various conditions. Notable additional properties include the optical, electrical, and magnetic behavior of materials.